Welcome everyone. We're continuing our work today in section 8.1 in which you're working with angle measures in polygons. And in is kind of not the right word this time because what we're going to do today is we're going to work with the exterior angles of polygons. It says there for your goal that you're going to solve problems using exterior angles of polygons. Well, let's begin by defining what an exterior angle of a polygon is. And I want to go back to the simplest of the polygons, the triangle. You learned way back when what the exterior angle of a triangle is. The way you make an exterior angle of a triangle, you'll recall, is you extend one of the sides of the triangle. So at a vertex. So say I extend this side right there. Here is an exterior angle for a triangle. Now you can make two exterior angles at each vertex. It's always going to be an angle between two sides of the triangle, like the extended side and the original side, if you will. If I'd wanted to, I could have made this exterior angle at the same vertex, right? There would be another exterior angle. But typically what happens is we just make one exterior angle at each vertex, all right? Extend one of the sides. So could do the same thing down here with this quadrilateral. It's got four sides. I could extend one side at each vertex. There's an exterior angle. There's an exterior angle. Here's another exterior angle. Right there. And then here's another exterior angle. Right here. Okay? And it doesn't matter how many sides a polygon has. I could do this for the hexagon as well. Draw an exterior angle there. Exterior angle there. Exterior angle there. And so forth all the way around. I'll just go ahead and finish this up. Alright, so actually you can draw twice as many exterior angles as a polygon has sides, but if we limit it to one exterior angle at each vertex, you're going to have the same number of exterior angles as you have interior angles and so forth. Alright, well next I want you to learn something about the measures of exterior angles. In this example, I'm asking for us to find the sum of the exterior angles in each figure. And you can see what I did was I just added angle measures to the figures from before. Okay, well let's check out the triangle here. Now, one of the things I'm going to do during this portion is I'm going to remind you what the sum of the interior angles for each of these polygons is. When we're dealing with a triangle, of course, you don't need a reminder, but the sum of the interior angles is 180 degrees. All right, well, what about the sum of the exterior angles? Well, if we make one exterior angle at each vertex, let's say we extend that side there, let's extend that side there, and let's extend this side up here. One thing we haven't discussed yet is what is the relationship between the measure of an exterior angle such as this one and the interior angle that it's adjacent with. Well, we haven't discussed it today. You learned this with triangles way back when. Those form a linear pair, don't they? An exterior angle always forms a linear pair with its adjacent interior angle. And so we could find then that this is a 120 degree angle. This would have to be 100 degrees. And this then would be 140 degrees. Alright, so the sum of the exterior angles then would be equal to 140 plus 100 plus 120. And that's equal to 360 degrees. Alright, so the sum of the exterior angles for a triangle happens to be twice the sum of its interior angles. Coincidental, maybe. We'll find out. Now, if we use that same logic, you know that the sum of the interior angles for a quadrilateral is 360 degrees. Well, let's create an exterior angle at each vertex. Let's create one there. Let's create one here. Here and there. Why not? And again, use the fact that they're linear pairs with the interior angle. So you would have 110 degrees. You'd have 80 degrees. 60 degrees, and 110 degrees again. So the sum of the exterior angles would be equal to 110 times 2, since we had two of those, or 2 of 20 in other words, plus 80 plus 60. Now, if our conjecture from before about the exterior angles having twice the sum that the interior angle measures have, then this would add to 720. But you see that it actually adds up to 360 degrees again. So a triangle and a quadrilateral each happen to have the same exterior angle measure sum. Let's do this with the hexagon as well. In fact, I'd like you to try it on your own, but then if you pause the video, I will be doing that real soon when you unpause. There's the 6 exterior angles I'm going to use. You didn't have to use the same ones, just had to use one at each vertex. And here are their measures. All right, now also I went ahead and wrote what the sum of the interior angles is. If you did n minus 2 times 180, 6 minus 2 is 4, times 180 is 720 degrees. 720 degrees in a hexagon, such as the one that you see right there. Now the sum of the interior angles, well, let's just add all those together. Let's see, 30 and 50 is 80, plus 70 is 150, plus 90 is 240, plus 80 is 320, plus another 40 is 360 degrees. Hey, how about that? Every time, no matter how many sides we made for our polygon, the sum of the exterior angles was 360 degrees. Now, guess what? That's a fact that you need to know. It's true for every polygon. The sum of the exterior angles for every polygon is always 360 degrees. In fact, that's called the exterior angles theorem. Let me write that fact down for you, and you should write it down as well. All right, the sum of the exterior angles of every polygon Now, I need to make the side note here that this is if you use one exterior angle at each vertex. The sum of the exterior angles of every polygon is 360 degrees. If you happen to use 2 per vertex, by the way, it'd be twice that, wouldn't it? 720 degrees. But for 1 per vertex, it's 360 degrees. Great. Now let's see how we can use exterior angles to answer some questions about polygons. Here, what I'm wanting you to do is to find the value of x. Now, there's actually 2 ways of going about finding the value of x here. One way would be to use interior angle measures and the fact that the sum of the interior angle measures in a pentagon is 540 degrees. And you know 4 of the 5 because it'd be easy to find out what this angle measure and this angle measure are. And, well, just add them up, subtract from 540. And the other thing that you can do is use the fact that the sum of the exterior angles is 360 degrees. Now, you didn't have to use the number of sides to figure out that the sum of the exterior angles was 360. You knew it was true regardless of the number of sides. So from that standpoint, it kind of has an advantage. Also, we're going to be working with smaller numbers most of the time when we're working with exterior angles. So I'm going to do that. Let's go ahead and find each of the exterior angle measures. You got 30 degrees there. Let's see, this will be 96 degrees. We already know this 75 degree angle and this 70 degree angle. So now we can simply say that x plus 30 plus 96 plus 75 plus 70 is equal to 360 because that's the sum of the exterior angles. And so you get x plus 271 is equal to 360. And so that tells us that x is equal to 89. Almost a right angle, but not quite. Well, excellent. So that's one way of using the sum of the exterior angles. Pretty easy, right? Okay, here's another use for exterior angles. And in particular, we're going to focus right now on exterior angles of polygons that are regular polygons. Now, you know that in a regular polygon, all of the interior angle measures are congruent, are equal to one another. Well, all the exterior angle measures are equal to one another in a regular polygon as well. So, how can we figure out, for instance, the exterior angle measure of a regular polygon that has 8 sides? Well, the sum of the exterior angle measures is 360 degrees, right? So can't we just divide 360 by how many sides there are to find out the measure of each exterior angle? Because the number of exterior angles corresponds with the number of sides. And that's exactly what we're going to do. All right, I'm going to write that up here. In a regular polygon, that's the only time this works, the measure of each exterior angle, not the sum, but the measure of each one, is equal to 360, the sum of all the exterior angles, divided by n, which is how many exterior angles there are. So here we just have to do 360 divided by 8. That tells us that each angle, exterior angle of a regular octagon, will be 45 degrees. All right? If we had a 25gon, the measure of each exterior angle would be 360 divided by 25. Which is 14.4 degrees. All right, now quick side note. If you know the measure of each exterior angle in a regular polygon, you also know the measure of each interior angle, because remember that exterior angles and interior angles always form linear pairs. So if I go back here and I wanted to know what each interior angle is, well, all I have to do then is subtract 45 from 180, and that would tell me that each interior angle measure for a regular octagon is 135 degrees. All right, you've probably worked that out somewhere else before at this point. And with this 25 gone then, we know each exterior angle is equal to 14.4, so we know each interior angle would have to be the supplement of that. And 180 minus 14.4 is equal to 165.6 degrees, right? All right, very good. Now, we can also kind of go the opposite way from what the original question asked up here in example A, where if you know the measure of each exterior angle, 24 degrees or 3 degrees or whatever they happen to be, then you can determine the number of sides that the regular polygon has quite simply as well. All right? Now, we know from what we just mentioned a moment ago that 360 divided by n would have to equal 24, because 360 divided by the number of sides is equal to the exterior angle measure. So that means 360 is equal to 24n, and n then would be 24 divided into 360, which is 15. All right, so a 15 gon, well, a regular 15 gon rather, would have 15, well, what am I trying to say? Would have 24-degree exterior angle measures. That's what I'm trying to say. There we go. Got it out. All right. Now, essentially, all I had to do was divide 360 by the exterior angle measure, and that told me the number of sides in that regular polygon. And that's what I could do here as well. I can really just do 360 divided by the measure of each exterior angle, and that will tell me the value of n, and that will give me that n is equal to 120. If you have a 120 gon, then each exterior angle is 3 degrees. One more problem I want to do with exterior angles, and it actually looks like an interior angle question at first, but I want to show you how we can do something that we did with interior angles a little more easily with exterior angles. The problem here says to find the value of n for a regular n-gon whose interior angles each measure 140 degrees. Essentially, then the same problem that we just looked at, except instead of telling you the measure of each exterior angle, telling you the measure of each interior angle. All right. Now, what we did in the previous video for that is we used this formula. The way you calculate the measure of the interior angle for a regular polygon is you find the sum of the interior angles, n minus 2 over 180, and you divide by n, since you have n equal angles, and that was equal to the interior angle measure, right? So in this case, we would set that equal to 140 degrees, and then multiply both sides by n, do a little bit of algebra, and you've got the value of n. Now, that's not that that's super complicated algebra, but check out this thing that's a little bit more simple. If each interior angle is 40 degrees, then each exterior angle measure would have to be 180 minus 140, or 40 degrees, right? And then if you know what the measure of each exterior angle is, well, all you have to do is 360 divided by the exterior angle measure to find out what the value of n is, and that tells you n is equal to 9. The algebra is certainly a lot simpler whenever you're using exterior angle measures than it is when you're using interior angle measures of a regular polygon to find the number of sides. Great, you should be experts at the angle measures, both interior and exterior, for regular polygons at this point. As always, appreciate you watching. Hope you learned something. See ya.